This is question 4 from the 2022 reserve paper for A2 Pure from CCEA. It's graph transformations and a little bit of functions. So let's take a wee look then at part A and see where we are. It says the graph of the function y equals f of x is kind of shown below here. The curve meets the axis at 2, 0. We can see that, and then 0, minus 1. Below shows 5 different graph transformations y equals f of x. These ones here, so these all have been transformed. And then on the next page it says complete the following statements. Y equals 2 f of x plus 3 is represented by graph whatever. So we need to work out where each of those are. So it's, I guess, a variation on what we're doing. So I'm going to try and fit both of these in, as you can see, and we'll kind of see what we think should happen. So this 2 stretches the graph twice as far away. That won't change, but that'll go down then to minus 2. The plus 3 moves everything 3 that way. So I'm looking for a graph then that has a minus 1 is the point P, and it's now kind of cutting in at minus 2. It's a wee bit further down. And so if I look here, there's the point there, look, that's kind of gone then kind of through to minus 3, and that one's kind of moved down, kind of stretched twice as far. So instead of being minus 1, it's minus 2. So my answer to that one then is going to be graph D. For this here, x minus 2 means it's moved to the right 2. So I'm looking for one where it's going to be then at minus 4. And then the minus f of x kind of flips it this way here. So it should be kind of looking like this, only crossing through then at 4, 0. And so that graph there is going to be my graph A. Do you see what's happened? The thing's been flipped upside down and everything's been moved to the right 2. So that one's then graph A. That's modulus of f of x, and let's take a wee look then at this one. Well, what's going to happen, it's going to come down here, and then anything that's below the graph is going to go up like that. So it's actually none of those, but it's going to be then kind of graph E. So hopefully you can see then where that one's come from. It's come there and move back up to there. And then f to the minus 1 of x, which is a bit rogue as well. So that's an inverse one. There's a couple of different ways we can look for the inverse. Effectively, the x and the y coordinates change round. And then it looks like it's been reflected in y equals f of x. I'll just draw it on here so you can kind of see. So you can reflect that in y equals f of x. You're going to get something kind of that looks a little bit like this. So if we take a look for that, then that one's going to be our graph B. Part B then is a functions question. So we have this function here, g of x is 2 plus cos x, h of x is 1 over 1 plus x. State the range of g of x. Well, it's between 0 and pi, so the graph of cos x between 0 and pi looks like this. So that would then kind of take it into pi. This graph here, it looks the same as this one, but everything's moved up 2. So that there's a point 1, and that's a point minus 1. But the fact that it's adding 2, this here moves up to 1, and this then will be 3. So my range then is going to be between, so the range of g of x is going to be in between 1 and 3, where g of x is a member of the real numbers. Find the inverse function h to the minus 1, stating its domain. So we have h of x is 1 over 1 plus x, and we're going to let y equal 1 over 1 plus x. And to find the inverse function, we're going to rearrange to get the x on its own and then change it back from there. So it's going to be y 1 plus x is 1, y plus x, y is going to be 1, x, y is 1 minus y, and then x is 1 minus y all over y. So my inverse function, h to the minus 1 of x, is going to be 1 minus x all over x. Here, they had x is a member of the real numbers. X can't be equal to minus 1. It can't be equal to minus 1 because that would give 0 on the bottom. So it's effectively just the same thing here. We have x is a member of the real numbers. We can have any number, but we can't have 0. So x is not equal to 0. Find the composite function hg of x stating its domain. So we need to take the g function and we need to substitute it in then to the h function. Hopefully you can kind of see both of those down there. So I'm taking the g, and anytime I see an x here, I'm exchanging it for a 2 plus cos x. So h of g of x is going to be 1 over 1 plus 2 plus cos x. So not much doing there. We know that that's 1 over 3 plus cos x. So that then is our composite function, and let's see, we take then the domain of the original one, so it's the g of x one we're looking at, so x is a member of the real numbers then between 0 and pi. And that's us.